Chapter 7. Takeoff and Departure Climbs. Introduction. This chapter discusses takeoffs and departure climbs in weight shift control, WSC. Aircraft with tricycle landing gear under normal conditions, crosswinds, and under conditions which require maximum performance. A thorough knowledge of takeoff principles, both in theory and practice, is extremely valuable throughout a pilot's career. It often prevents an attempted takeoff that would result in an accident, or during an emergency, makes a takeoff possible under critical conditions in which a pilot with less knowledge and lesser technique would normally fail. End of page 7-1. The takeoff, though relatively simple, often presents the most hazards of any part of a flight. The importance of thorough knowledge, faultless technique, and sound judgment cannot be overemphasized. It must be remembered that the manufacturer's recommended procedures, including configuration and airspeeds, and other information relevant to takeoffs and departure climbs in a specific make and model WSC aircraft are contained in the Airplane Flight Manual/Pilot's Operating Handbook, AFM/POH. If any of the information in this chapter differs from the manufacturer's recommendations as contained in the AFM/POH, the manufacturer's recommendations take precedence. Terms and definitions. Although the takeoff and climb is one continuous maneuver, it is divided into three separate steps for purposes of explanation: takeoff roll, liftoff, and initial climb after becoming airborne. Figure 7.1. 1. Takeoff roll, ground roll, the portion of the takeoff procedure during which the aircraft is accelerated from standstill to an airspeed that provides sufficient lift for it to become airborne. 2. Liftoff, rotation, the act of becoming airborne is a result of the wings lifting the aircraft off the ground or the pilot rotating the nose up, increasing the angle of attack to start a climb. 3. Initial climb, begins when the aircraft leaves the ground and an initial pitch attitude has been established to climb away from the takeoff area. Normally, it is considered complete when the aircraft has reached a safe maneuvering altitude, or an en route climb has been established. Prior to takeoff. Before taxiing onto the runway or takeoff area, the pilot should ensure that the engine is operating properly and that all controls, including trim, if equipped, are set in accordance with the before takeoff checklist. In addition, the pilot must make certain that the approach and takeoff paths are clear of other aircraft. At uncontrolled airports, pilots should announce their intentions on the Common Traffic Advisory Frequency, CTAF, assigned to that airport. When operating from an airport with an operating control tower, pilots must contact the tower operator and receive a takeoff clearance before taxiing onto the active runway. It is not recommended to take off immediately behind another aircraft, particularly large, heavily loaded transport airplanes, because of the wake turbulence that is generated. Even smaller aircraft can generate vortices that can cause the WSC aircraft to lose control during takeoff. Always wait for aircraft vortices to clear before taking off. While taxiing onto the runway, the pilot can select ground reference points that are aligned with the runway direction as aids to maintaining directional control during the takeoff. These may be runway centerline markings, runway lighting, distant trees, towers, buildings, or mountain peaks. Normal takeoff. A normal takeoff is one in which the aircraft is headed into the wind, or the wind is very light. Also, the takeoff surface is phi rm and of sufficient length to permit the aircraft to gradually accelerate to normal liftoff and climb out speed, and there are no obstructions along the takeoff path. End of page 7-2. There are two reasons for making a takeoff as nearly into the wind as possible. First, the aircraft's speed while on the ground is much lower than if the takeoff were made downwind, thus reducing wear and stress on the landing gear. Second, a shorter ground roll and, therefore, much less runway length is required to develop the minimum lift necessary for takeoff and climb. Since the aircraft depends on airspeed in order to fly, a headwind provides some of that airspeed, even with the aircraft motionless, from the wind flowing over the wings. Takeoff roll. After taxiing onto the runway, the WSC aircraft should be carefully aligned with the intended takeoff direction and the nosewheel positioned straight down the runway on the centerline. After releasing the brakes, the throttle should be advanced smoothly and continuously to takeoff power. Figure 7.2. This can be done with the foot or the hand cruise throttle. The advantage of using the foot throttle is that the takeoff can be aborted quickly if required. The disadvantage is that the foot can slip off or be knocked off during the critical takeoff phase of flight. The advantage of using the hand cruise throttle during takeoff is having a solid and set throttle that the pilot does not have to worry about holding during the takeoff phase of flight. Students have been known to release the foot throttle on takeoff, resulting in catastrophic consequences during the liftoff and initial climb phases of flight. Students may be encouraged to use the hand throttle by the instructor, or the instructor must be able to immediately apply the hand or secondary foot throttle if a student lets up on the throttle during this critical takeoff and climb phase. An abrupt application of power may cause the aircraft to yaw sharply to the left or right depending on the propeller rotation, because of the torque effects of the engine and propeller. This is most apparent in high horsepower engines. As the aircraft starts to roll forward, the pilot should ensure that both feet are on the front steering fork and not applying the brake. As speed is gained, the control bar fore and aft pitch tends to assume a neutral trim position. The wing should be maintained level side to side with the control bar. At the same time, directional control should be maintained with smooth, prompt, positive nosewheel steering throughout the takeoff roll. The effects of engine torque at the initial speeds tend to pull the nose to the left or right depending on the propeller rotation. The pilot must steer the WSC aircraft straight down the middle of the runway with the feet. The positioning of the wing has no effect of steering on the ground. The common saying among WSC pilots is, "You steer with your feet, you fly with your hands." While the speed of the takeoff roll increases, increasingly more pressure is felt on the control bar to the ground roll trim position. Letting the wing pitch pressures determine the fore and aft control bar position provides the least drag for the WSC aircraft to accelerate. The pilot maintains directional control down the center of the runway with the foot steering, keeps the wings level side to side, and allows the wing to determine the pitch angle during the acceleration. Lift-off. Since a good takeoff depends on the proper takeoff attitude, it is important to know how this attitude appears and how it is attained. The ideal takeoff attitude requires only minimum pitch adjustments shortly after the airplane lifts off to attain the speed for the best rate of climb, Vy. Figure 7.3. The pitch attitude necessary for the aircraft to accelerate to Vy speed should be demonstrated by the instructor and memorized by the student. Initially, the student pilot may have a tendency to hold excessive control bar forward/nose-up pressure just after liftoff, resulting in an abrupt pitch-up. The flight instructor should be prepared for this. For a normal takeoff, the WSC aircraft should lift off the ground gradually and smoothly. Each type of WSC aircraft has a best pitch attitude for normal liftoff. However, varying conditions may make a difference in the required takeoff technique. A rough field, a smooth field, a hard surface runway, or a shorter, soft, muddy field calls for a slightly different technique, as does smooth air, in contrast to a strong, gusty wind. The different techniques for those other than normal conditions are discussed later in this chapter. As the WSC aircraft accelerates and obtains the speed it needs to lift off, a slight push forward on the control bar provides the initial attitude to lift off. End of page 7-3. This is often referred to as rotating. At this point, the climb speed should be immediately established for the particular condition. For calm winds, this would be the trim position or the manufacturer recommended takeoff safety airspeed. The wings must be kept level by applying side-to-side pressure as necessary. Since some forward pressure was required to rotate, this pressure must be relaxed smoothly so that takeoff attitude is not too high. This requires the control bar being brought back to trim and applying some nose-down pressure to avoid popping off as the WSC aircraft leaves the ground. Each make and model is different, and the high-power WSC aircraft must provide more nose-down pressure after rotation to keep the attitude low. A good takeoff is a smooth and gradual liftoff. It is important to hold the correct attitude constant after rotation and liftoff. As the aircraft leaves the ground, the pilot must continue to be concerned with maintaining the wings in a level attitude, as well as holding the proper pitch attitude. An outside visual scan to attain/maintain proper pitch and bank attitude must be intensified at this critical point. During takeoffs in a strong, gusty wind, it is advisable that an extra margin of speed be obtained before the WSC aircraft is allowed to leave the ground. A takeoff at the normal takeoff speed may result in a lack of positive control, or a stall, when the WSC aircraft encounters a sudden lull in strong, gusty wind, or other turbulent air currents. In this case, the pilot should allow the aircraft to stay on the ground longer by pulling the control bar towards the chest, keeping the nose down to attain more speed, then make a smooth, positive rotation to leave the ground. Initial climb. Upon liftoff, the WSC aircraft should be flying at the approximate pitch attitude that allows it to accelerate to at least the manufacturer's takeoff safety speed. This is usually close to the best climb rate speed Vy, providing the greatest altitude gain in a period of time. Higher speeds should be used if the air is turbulent to assure the WSC does not stall from a strong wind gust. This speed should be maintained during the initial climb out in case of an engine failure. This is especially important with higher power engines and larger wings to avoid a high pitch attitude during this critical phase of the takeoff. With a lower pitch attitude and a faster speed, the WSC aircraft can recover easier from an engine failure on takeoff. This is discussed in greater detail in the Emergency Procedures chapter of this handbook. For example, from liftoff to 200 feet, it is a good practice to keep a low pitch angle to anticipate an engine failure. Above 200 feet, Vy can be used as a climb speed. Figures 7, 4 and 7-5. After liftoff and throughout the climb, the engine instruments should be checked for proper cooling and oil pressure, if so equipped, since this is the critical time when temperature rises and should stabilize within the manufacturer's specifications. The manufacturer's recommended takeoff power should be maintained until reaching an altitude of at least 500 feet above the surrounding terrain or obstacles. The combination of Vy and takeoff power assures the maximum altitude gained in the time during takeoff. This provides the pilot the greatest altitude from which the aircraft can be safely maneuvered in case of an engine failure or other emergency. End of page 7-4. Since the power on the initial climb is fixed at the takeoff power setting, the airspeed must be controlled by making slight pitch adjustments using the control bar. However, the pilot should not fixate on the airspeed indicator when making these pitch changes, but continue to scan outside to adjust the attitude in relation to the horizon and the feel of the aircraft. The WSC aircraft can be flown by using bar position and the feel of the air to determine proper airspeed. It is not necessary to look at the airspeed indicator to determine exact airspeed. In accordance with the principles of flying a WSC aircraft, the pilot should first make the necessary pitch change with reference to the bar position, and then glance at the airspeed indicator as a check to see if the new speed is correct. After the recommended climb airspeed has been established and a safe maneuvering altitude has been reached, the power should be adjusted to the recommended climb setting, if different, and the WSC aircraft trimmed, if so equipped, to relieve the control pressures. This makes it easier to hold a constant attitude and airspeed. During initial climb, it is important that the takeoff path remain aligned with the runway to avoid drifting into obstructions or the path of another aircraft that may be taking off from a parallel runway. Proper scanning techniques are essential to a safe takeoff and climb, not only for maintaining attitude and direction, but also for collision avoidance in the airport area. Figures 7, 6. When the student pilot nears the solo stage of flight training, it should be explained that the aircraft's takeoff performance is much different when the instructor is out of the aircraft. Due to decreased load, the WSC aircraft becomes airborne sooner and climbs more rapidly. The pitch attitude that the student has learned to associate with initial climb differs significantly due to decreased weight. This can be a dramatic effect since a 250-pound instructor could reduce the total weight of the WSC aircraft by 30%. This gives the student the sensation of lying on his or her back during initial takeoff, and the reaction is to let off the throttle with serious consequences if the student is using the foot throttle. It must be emphasized by the instructor that the student will seem to be rotated and going straight up, but not to let up on the throttle. The reaction of the student is to pull in the control bar to lower the high pitch attitude. This is where the cruise throttle should be used to eliminate this common problem. The increase in performance is significant when the student first solos in the same aircraft, which must be explained and understood. If the situation is unexpected, it may result in increased tension that may remain throughout the flight. Frequently, the existence of this tension and the uncertainty that develops due to the perception of an abnormal takeoff results in poor performance on the subsequent landing. End of page 7-5. Common errors in the performance of normal takeoffs and departure climbs are: 1. Failure to adequately clear the area prior to taxiing into position on the active runway. 2. Abrupt use of the throttle. 3. Letting off the foot throttle after takeoff. 4. Failure to check engine instruments for signs of malfunction after liftoff and climb. 5. A failure to anticipate the aircraft's left-turning tendency on initial acceleration and takeoff. 6. Overcorrecting for left-turning tendency. 7. Overcorrecting for roll. 8. Relying solely on the airspeed indicator rather than developing a feel for indications of speed and controllability during acceleration and liftoff. 9. Failure to attain proper liftoff attitude. 10. Over-control of pitch during initial liftoff to climb out. 11. Failure to attain/maintain best rate of climb airspeed, VY. 12. Failure to employ the principles of attitude flying during climb out, resulting in chasing the airspeed indicator. Crosswind takeoff. While it is usually preferable to take off directly into the wind whenever possible or practical, there are many instances when circumstances or judgment indicate otherwise. Therefore, the pilot must be familiar with the principles and techniques involved in crosswind takeoffs, as well as those for normal takeoffs. The manufacturer's maximum wind and crosswind component in the POH should not be exceeded. The following procedures are for operation within these limitations. Takeoff roll. The technique used during the initial takeoff roll in a crosswind is generally the same as used in a normal takeoff, except that the pilot must control the wing's tendency to weather vane into the wind during the takeoff roll. Additionally, the pilot should keep the WSC aircraft on the ground and accelerate to a higher speed before rotation. As the aircraft is taxied into takeoff position, it is essential that the windsock and other wind direction indicators be checked so that the presence of a crosswind may be recognized and anticipated. During taxi and takeoff, the windward side of the wing needs to be slightly lowered so as to not let the wind get under it and lift it off, but not too low or additional pilot effort is required and unnecessary stress is placed on the carriage. The crosswind takeoff is performed similar to the normal takeoff except two different techniques are utilized. First, as the WSC aircraft accelerates and the pilot steers the carriage straight down the runway, the wing will want to weather vane into the wind. This creates stress on the wing attachment to the carriage mast, and the keel of the carriage. Therefore, the pilot must hold the wing control bar straight to the carriage, which requires significant force and muscle. Second, the pilot must accelerate to a higher speed before rotating to account for the crosswind component. This requires the nose to be held down to prevent the WSC from popping off the ground before the higher airspeed is obtained. Since this technique requires the pilot to muscle the wing rather than using a light touch, it requires a mastery of the normal takeoff before crosswind takeoffs should be attempted. As the WSC aircraft accelerates down the runway, the forces of the wing try to weather vane it into the wind and the nose raises up to trim. The wing should be held straight with the nose down until rotation, where the wing is held straight and the nose raised. Rotation and liftoff. When a faster rotation speed than normal takeoff is achieved, a smooth but quicker push-out to rotate is desired to get the front and rear wheels into the air quickly, avoiding any tendency to remain on the rear wheels. After liftoff, the WSC automatically rotates into the relative wind since momentum is straight down the runway and the characteristics of the wing point it directly into the relative wind. The WSC sets up the wind correction angle, or crab angle as it is also called, as it lifts off. Figure 7.7. Initial climb. After liftoff, the WSC aircraft is pointed toward the wind and the ground track is headed straight down the runway centerline. Maintain this ground track aligned directly down the centerline of the runway, crabbing into the wind. Crabbing is a term used to adjust flight controls into the crosswind to maintain a straight ground track while the WSC is pointed towards the wind, as seen in Figure 7.8. To maintain the ground track, it is important to look straight down the runway centerline and steer to stay on that ground track even though the WSC is pointed towards the wind and not directly down the runway. Because the force of a crosswind may vary markedly within a few hundred feet of the ground, frequent checks of actual ground track should be made, Figure 7.7, or the WSC could drift to the side if the wind correction angle is not maintained. The remainder of the climb technique is the same used for normal takeoffs and climbs, maintaining the proper ground track with the proper wing correction angle/crab angle. Figure 7.8. End of page 7 to 6. In addition to normal takeoffs, additional common errors in the performance of crosswind takeoffs are: 1. Letting the windward side of the wing get too high. 2. Allowing the wing to weather vane into the wind during the takeoff roll. 3. Not obtaining additional speed before rotation. 4. Too slow of a rotation during liftoff. 5. Inadequate drift correction after liftoff. Ground effect on takeoff. Ground effect is a condition of improved performance encountered when the aircraft is operating very close to the ground. Ground effect can be detected and measured up to an altitude of about 1 wingspan above the surface. Figures 7, 9. However, ground effect is most significant when the WSC aircraft is maintaining a constant attitude at low airspeed and low altitude. Examples are during takeoff when the aircraft lifts off and accelerates to climb speed, and also during the landing flare before touchdown. When the wing is under the influence of ground effect, there is a reduction in upwash, downwash, and wingtip vortices. Since the WSC wing is a high wing aircraft, the effects are not as pronounced as a low wing airplane, but during rotation, the reduction in induced drag is about 25% and decreases as the WSC aircraft climbs. At high speeds where parasite drag dominates, induced drag is a small part of the total drag. Consequently, the effects of ground effect are of greater concern during takeoff and landing. End of page 7 to 7. On takeoff, the takeoff roll, liftoff, and the beginning of the initial climb are accomplished in the ground effect area. As the aircraft lifts off and climbs out of the ground effect area, the following occurs. 1. The WSC aircraft requires an increase in angle of attack to maintain the same lift coefficient. 2. The WSC aircraft experiences an increase in induced drag and thrust required. Due to the reduced drag and ground effect, the aircraft may seem capable of taking off below the recommended airspeed with less thrust. However, as the aircraft rises out of ground effect with an insufficient airspeed, initial climb performance may prove to be marginal due to increased drag. Under conditions of high density altitude, high temperature, and/or maximum gross weight, the aircraft may become airborne at an insufficient airspeed but unable to climb out of ground effect. Consequently, the aircraft may not be able to clear obstructions or may settle back on the runway. The point to remember is that additional power is required to compensate for increases in drag that occur as an aircraft leaves ground effect. But during an initial climb, the engine is already developing maximum power. The only alternative is to lower pitch attitude to gain additional airspeed, which results in inevitable altitude loss. Therefore, under marginal conditions, it is important that the aircraft take off at the recommended speed that provides adequate initial climb performance. Ground effect is important to normal flight operations. If the runway is long enough, or if no obstacles exist, ground effect can be used to advantage by utilizing the reduced drag to improve initial acceleration. Additionally, the procedure for takeoff from unsatisfactory surfaces is to take as much weight on the wings as possible during the ground run, and to lift off with the aid of ground effect before true flying speed is attained. It is then necessary to reduce the angle of attack to attain normal airspeed before attempting to fly away from the ground effect area. Short field takeoff and steepest angle climb. Takeoffs and climbs from fields in which the takeoff area is short or the available takeoff area is restricted by obstructions require the pilot to operate the WSC aircraft at the limit of its takeoff performance capabilities. To depart from such an area safely, the pilot must exercise positive and precise control of attitude and airspeed so that takeoff and climb performance results in the shortest ground roll and the steepest angle of climb. The achieved result should be consistent with the performance section of the AFM/POH. In all cases, the power setting, trim setting, airspeed, and procedures prescribed by the manufacturer should be followed. End of page 7 to 8. In order to accomplish a short field takeoff and steepest angle climb safely, the pilot must have adequate knowledge in the use and effectiveness of the best angle of climb, Vx. Speed and the best rate of climb, Vy. Speed for the specific make and model of WSC aircraft being flown. The speed for Vx is that which results in the greatest gain in altitude for a given distance over the ground. Vx is usually less than Vy but greater than minimum controlled airspeed. It should be noted that this maneuver is not performed in normal situations. Flying at VX speed close to the ground in gusty winds can result in a stall with catastrophic consequences. If clearing an obstacle is questionable, the WSC aircraft should be packed up and trailered away. If a pilot decides to perform a short FAA ELD takeoff, then a number of factors can be optimized to contribute to a short field takeoff, such as leaving your passenger and/or baggage in the area, waiting for favorable winds or lower density altitude, and picking the longest runway path with the shortest obstacle to clear. However, if a short field takeoff is going to be performed and all possible factors have been optimized, the following procedure is provided. The procedure is similar to the normal takeoff, but the following additional procedure is used for this maneuver. Takeoff roll. Taking off from a short field requires the takeoff to be started from the very beginning of the takeoff area. The WSC manufacturer's recommended specific trim setting should be set before starting the takeoff roll. This permits the pilot to give full attention to the proper technique and the aircraft's performance throughout the takeoff. Some authorities prefer to hold the brakes until the maximum obtainable engine revolutions per minute (RPM) is achieved before allowing the WSC aircraft to begin its takeoff run. However, it has not been established that this procedure results in a shorter takeoff run in all WSC aircraft, many of which cannot hold the brakes at full throttle. If the brakes are not held with the throttle advanced to full and then released, takeoff power should be applied immediately to full throttle as fast as possible without the engine bogging down to accelerate the aircraft as rapidly as possible. The WSC aircraft should be allowed to roll with the wing finding the trim position for minimum drag during acceleration to the liftoff speed. Liftoff and climb out. At VX speed, the WSC aircraft should be smoothly and firmly rotated by applying control bar forward pressure to an attitude that results in the VX airspeed. After becoming airborne, a wings level climb should be maintained at VX until obstacles have been cleared. Thereafter, the pitch attitude may be lowered slightly and the climb continued at VY speed until reaching a safe maneuvering altitude. Remember that an attempt to rotate off the ground prematurely or to climb too steeply may cause the WSC aircraft to settle back to the runway or into the obstacles. Even if the aircraft remains airborne, the initial climb remains flat and climb performance/obstacle clearance ability is seriously degraded until VX airspeed is achieved. Figures 7, 10. End of page 7 to 9. In addition to normal takeoffs, common errors in the performance of short field takeoffs are: 1. Deciding to do a questionable short field takeoff when the WSC aircraft can be packed up and driven away. 2. Failure to adequately determine the best path with the longest run and shortest obstacle. 3. Failure to utilize all available runway/takeoff area. 4. Failure to wait for the best atmospheric conditions of density, altitude, and wind direction. 5. A failure to reduce all possible weight from the WSC aircraft. 6. Failure to have the WSC aircraft properly trimmed prior to takeoff. 7. Premature liftoff resulting in high drag. 8. Holding the WSC aircraft on the ground unnecessarily. 9. Inadequate rotation resulting in excessive speed after liftoff. 10. Inability to attain/maintain best VX airspeed. 11. Fixation on the airspeed indicator during initial climb. Soft/rough field takeoff and climb. Takeoffs and climbs from soft fields require the use of operational techniques for getting the WSC aircraft airborne as quickly as possible to eliminate the drag caused by tall grass, soft sand, mud, and snow, and may or may not require climbing over an obstacle. The technique makes judicious use of ground effect and requires a feel for the WSC aircraft and fine control touch. These same techniques are also useful on a rough field where it is advisable to get the aircraft off the ground as soon as possible to avoid damaging the landing gear. Soft surfaces or long, wet grass usually reduce the aircraft's acceleration during the takeoff roll so much that adequate takeoff speed might not be attained if normal takeoff techniques were employed. It should be emphasized that the WSC aircraft is different from most aircraft. The high wing creates a high center of gravity in which the front wheel can bog down in soft fields and flip the WSC aircraft forward. The propeller in the back pushing down on the front wheel also contributes to this unique situation. This is a limitation for WSC aircraft that should not be ignored. WSC aircraft that land in soft fields or sand may not be able to take off. There is a wide variation of manufacturer designs, with the least preferable being a skinny, high-pressure, highly loaded front tire. WSC aircraft with large wide tires that can be operated at low pressure are designed for operation in soft and rough fields. Figures 7:11 through 7-13. Correct takeoff procedure for soft fields and rough fields is quite different from that appropriate for short fields with firm, smooth surfaces. To minimize the hazards associated with takeoffs from soft or rough fields, support of the aircraft's weight must be transferred as rapidly as possible from the wheels to the wings as the takeoff roll proceeds. Establishing and maintaining a relatively high angle of attack with a nose high pitch attitude as early as possible achieves this. End of page 7-10. Figure 7:12. Example of a WSC aircraft designed with a wide low-pressure front wheel for soft field operation. Figure 7:13. Grass fields are commonly used for WSC operations but require a longer time to accelerate to takeoff speed. End of page 7-11. Stopping on a soft surface, such as mud, snow or sand, might bog the aircraft down. Therefore, it should be kept in continuous motion with sufficient power while lining up for the takeoff roll. Takeoff roll. As the aircraft is aligned with the takeoff path, takeoff power is applied smoothly and rapidly. As the aircraft accelerates, the control bar is moved full forward to the front tube to establish a positive angle of attack and to reduce the weight supported by the nose wheel, because any lift on the wing takes load off of the landing gear. When the aircraft is held at a nose-high attitude throughout the takeoff run and as speed increases and lift develops, the wings progressively relieve the wheels of more and more of the WSC's weight, thereby minimizing the drag caused by surface irregularities or adhesion. If this attitude is accurately maintained, the aircraft virtually flies itself off the ground, becoming airborne at airspeed slower than a safe climb speed because of ground effect. Figure 7:14. Liftoff and initial climb. After becoming airborne, the nose should be lowered very gently with the wheels clear but just above the surface to allow the aircraft to utilize ground effect to accelerate to Vy, or Vx if obstacles must be cleared. Extreme care must be exercised immediately after the aircraft becomes airborne and while it accelerates to avoid settling back onto the surface. An attempt to climb prematurely or too steeply may cause the aircraft to settle back to the surface as a result of losing the benefit of ground effect. An attempt to climb out of ground effect before sufficient climb airspeed is attained may result in aircraft incapacity to continue climbing as the ground effect area is traveled, even with full power for lower-powered WSC aircraft. Therefore, it is essential that the aircraft remain in ground effect until at least Vx is reached. This requires a feel for the WSC aircraft and a very fine control touch in order to avoid over-controlling the pitch control as required control pressures change with aircraft acceleration. Simply getting off the ground as quickly as possible and flying in ground effect is the goal. In addition to normal takeoffs, additional common errors in the performance of soft/rough field takeoffs are: 1. Attempting a takeoff with a WSC that is not equipped with the proper tires. 2. Minimum air pressure not used in tires. 3. Insufficient control bar forward pressure during initial takeoff roll, resulting in inadequate angle of attack. 4. Poor directional control. 5. Climbing too steeply after liftoff. 6. Abrupt and/or excessive pitch control while attempting to level off and accelerate after liftoff. 7. Allowing the aircraft to mush or settle, resulting in an inadvertent touchdown after liftoff. 8. Attempting to climb out of ground effect area before attaining sufficient climb speed. Rejected takeoff/engine failure. Emergency or abnormal situations can occur during a takeoff that requires a pilot to reject the takeoff while still on the runway. Circumstances such as a malfunctioning power plant, items dislodging during takeoff, inadequate acceleration, runway incursion, or air traffic conflict may be reasons for a rejected takeoff. End of page 7-12. Prior to takeoff, the pilot should have in mind a point along the runway at which the aircraft should be airborne. If that point is reached and the WSC aircraft is not airborne, immediate action should be taken to discontinue the takeoff. Properly planned and executed, chances are excellent the aircraft can be stopped on the remaining runway without using extraordinary measures, such as excessive braking that may result in loss of directional control, damage, and/or personal injury. In the event a takeoff is rejected, the power should be reduced to idle or the engine shut off and maximum braking applied while maintaining directional control. If it is necessary to shut down the engine due to a fire, the fuel supply should be shut off and the magnetos turned off. In all cases, the manufacturer's emergency procedure should be followed. What characterizes all power loss or engine failure occurrences after liftoff is urgency. In most instances, the pilot has only a few seconds after an engine failure to decide what course of action to take and to execute it. Unless prepared in advance to make the proper decision, there is an excellent chance the pilot will make a poor decision, or make no decision at all and allow events to rule. In the event of an engine failure on initial climb out, the pilot's first responsibility is to maintain aircraft control. At a climb pitch attitude without power, the WSC is at or near a stalling angle of attack. It is essential the pilot immediately lower the pitch attitude by pulling the control bar back to the chest immediately to prevent a stall. As discussed earlier in the climb section, a preventative measure is to climb to a safe altitude. 200 feet was used as an example. At least the minimum safe climb speed is recommended by the manufacturer to lower pitch angle as a safety measure for this situation to minimize a high pitch angle close to the ground. The pilot should establish a controlled glide toward a plausible landing area, preferably straight ahead on the remaining runway. Noise abatement. Aircraft noise problems have become a major concern at many airports throughout the country. Many local communities have pressured airports into developing specific operational procedures that help limit aircraft noise while operating over nearby areas. For years now, the Federal Aviation Administration, FAA, airport managers, aircraft operators, pilots, and special interest groups have been working together to minimize aircraft noise for nearby sensitive areas. As a result, noise abatement procedures have been developed for many of these airports that include standardized profiles and procedures to achieve these lower noise goals. Airports that have noise abatement procedures provide information to pilots, operators, air carriers, air traffic facilities, and other special groups that are applicable to their airport. These procedures are available to the aviation community by various means. Most of this information comes from the Airport/Facility Directory, /FD. Local and regional publications, printed handouts, operator bulletin boards, safety briefings, and local air traffic facilities. At airports that use noise abatement procedures, reminder signs may be installed at the taxiway hold positions for applicable runways. These are to remind pilots to use and comply with noise abatement procedures on departure. Pilots who are not familiar with these procedures should ask the tower or air traffic facility for the recommended procedures. In any case, pilots should be considerate of the surrounding community while operating their aircraft to and from such an airport. This includes operating as quietly, yet safely as possible. Chapter Summary. Normal takeoff is straight down runway centerline with rotation at proper airspeed and initial climb at safe airspeed and moderate pitch angle to account for engine failure. Once to safe maneuvering altitude on route climb speed is maintained. Crosswind takeoffs are similar to normal takeoffs except wing must be held straight to ground path during acceleration and greater speed is obtained before rotation. Short field takeoffs are performed by ensuring that sufficient runway is available for takeoff and utilizing best angle of climb speed, VX, until obstacle is cleared. Rough or soft FI ELD takeoffs are performed by keeping the weight off the nosewheel and lifting off into the ground effect to gain speed as soon as possible. Precaution should always be taken by climbing at faster airspeeds and lower pitch angles in case of an engine failure/rejected landing. End of page 7 to 13. End of chapter 7. Please like, share, and subscribe to our channel. Thank you. Chapter 8 is coming soon.